But nonetheless, would still forge ahead. So, good evening, Victor. Good evening, Alpha. I guess I pronounced that correctly. Sorry, just to confirm, is there an echo on my microphone? Okay, we are good. All right, so I would have loved to start by giving us some information that I think will be very important to us. But they're looking at the number of persons available. I wouldn't want to repeat myself, so I don't know if I'll have to allow that to come later when we have more persons. So I don't know. Time is not on our side, and we know the challenge of devices that we use, battery power, and data consumption. So the more we linger, the more our battery power gets diminished, and all right. Sorry about that. Okay, so don't know if I should go ahead to share my screen. Okay, I guess I'll just have to go ahead. I don't know. So many persons will have to go back to this video to know what we have done. I just have to continue. So first, Victor Shea, you have written the certification exams. So that I can know what to do.
Yes, I've written it.
Okay. All right. So I just want to, I know we've started a new track, but I just wanted, I discovered that some of us still do not understand concept of supervised learning when we are predicting models. So I just want to just use a notebook on data camp to explain to us. So we just go step by step to really understand what it's all about. All right, so I would, what's it called? I'll share my screen now. All right, I don't know if you can see my screen. All right,
Yeah.
all right. So we're looking at supervised learning. Um, so we first and foremost, I might want to ask. I might want to ask, what is a supervised learning? Or what are the different ways that we can actually train a machine to be able to make accurate predictive models, accurate prediction, if you like. So not to waste time, we have supervised learning, we have unsupervised learning, we have reinforcement. All right, so supervised learning is when we actually use when the machine is learning from labeled data. What do you mean by labeled data? It means that the data has already been categorized and labeled already. So what the machine does is to learn from the labeled data and use it to make predictions, or use it to make to bring about a model that will make good predictions. Unsupervised learning is when you leave the machine alone, right, to make sense of the data. All right. So yeah, to make sense of the data, all right, to actually be able to, make sense out of them and probably categorize them and observe the patterns, observe the trends, and learn from it. Okay, that's where we now have the idea of classifications, k-means classification, clustering, where um, what is close to a data point, all right, will determine a lot. So I will just dwell on supervised learning. So um, what we do is to predict the value of a target variable given a set of features. I know it's important that some of them might be saying, I've done this a lot of times. This is the basics of machine learning that I think we need to get well, even as we are already dealing with data science track, dealing with how to work with APIs, how to import other kinds of data sets. It's important, I think, for us to know this. So, okay, so what we do in supervised learning is that we predict the values of a target variable given a set of features. For example, predicting if a customer would buy a product that based on their location and the last 5 purchases. So, for example, you want to use a known data. In this case of our example, the location of a customer and their last 5 purchases. All right. You want to, I'm sorry, please hold on. All right. So sorry about that. You want to be able to determine whether they would buy a product or not. And how you want your machine to know that is by making observations on a data set already that has been trained, so excuse me, a data set that you're using to train the machine. And that data set would have had all of this information, the location of customers, their last 5 purchases, and what they bought. So it's more like the machine is looking at a pattern and using that pattern to make predictions for a test data, for a new data set. It's, some of us might be asking, why is this important? It's very important, to there are different, especially as regards finance, when it comes to maybe customer segmentation or churn analysis, to detect if a customer will churn or not. Some of these financial services where you might need to subscribe, looking at the historical data of customers, you can make sense out of it to know at what season or to know the kind of persons that will churn. All right, to know the feature importance, because each features have different scale of importance. So sometimes you can be able to know that, oh, certain people at certain age range would churn, certain people at certain age range would not churn. We have um, regression. Regression is a kind of supervised learning that is actually used for continuous variable, to predict continuous variable. All right. Example of continuous variable is a house price. All right. You know, I told you that we have two kinds of numerical variable. We have continuous and we have discrete. All right. Discrete is actually count. So, for example, number of children that a customer has, we say five, say one, two. Those are discrete. Then the prices of houses, the prices of goods, um, temperature, if you like, they are continuous variable. So we use regression models, linear regression or logistic regression models for those kind of predictions. We have classification. Classification models, we use it to predict binary outcome. Yes, a yes or a no kind of outcome. All right. So if a customer will or will not churn. All right. So we use classification models for those kind of predictions. So we have a data set here, loan. So we see the columns here for the data set, the loan ID, the gender, the marital status, dependent, blah, 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 blah. So first and foremost, let's see if we can be able to import the necessary libraries, the basic libraries that you need when you are making, when you're creating a model. Right, so basic ones, your NumPy, plus you import pandas. Sometimes you might need to import, and you might need to make plots, so to be able to get insights on your data. All right, so of course we know that the library, Python library for predictive models is scikit-learn. We use it for machine learning. All right, so oh sorry, let me write it as full. It's written as SK learn. So the first thing we do is the model selection. Okay. From this we import our train test split. How many percent do you have in this score now? Okay. Welcome, Bola. Victor has left us. Right, I'll just continue. So what model? In this case, we might use a linear model. But we're going to use the logistic regression. Then the evaluation. These are the basic library that we need. So use confusion matrix. Maybe confusion matrix display. All right, so let's just read in our data set. Let's call it loan. Go to edit with CSV. Loans CSV. Let's run this. Oh, sorry. Ah. Not I'm not spelling this correctly. Math plot CSV pilot YP rather SPLC. I get it. You should help me. Is there no longer any library as matplotlib? Is there anything that is wrong? There's no spelling that is wrong here. Oh, it's too much, Gary. All right, so so let's preview our data. So look at the columns that we have. This is a categorical, this is discrete, numerical discrete variable. This is a categorical. This is nominal. Self-employed categorical data is nominal. Applicant income, a continuous variable, continuous variable. Long term, this 60, this long term, or is a below amount, term of months, okay. Property area is a categorical data, nominal, non-status, it's a categorical data. Yes or no kind of stuff. So exploratory data analysis, of course, when you are making a model, creating a model, the first thing to do is to explore your data before you now begin to engineer the features. All of this is what we put under data processing. All right, so we can't just dive straight into machine learning. We need to understand and format our data for model. What are we looking for? So there are 4 things you look out for when you are exploring your data. You look at the cleanliness, the distributions, the relationships, and then feature engineering. When you come at cleanliness, are there missing data? Right? Are the columns set to the correct data type? I just want us to take note of this, very important. It can be a guide to us. The distribution of the data, are they normally distributed? Because normal distribution is actually very, very, very palatable for machine learning algorithms or models. Right? Binomial, can have issues for. So we need to ensure that our data is normally distributed. Do we have outliers? If we have outliers, say for example, we have a very high loan amount, or outliers, so we can deal with the relationships. If a data is strongly correlated with the target variable, it might be a good feature. So sometimes it's good to actually check relationship using your data visualizations to be able to have an idea of which feature might be the best, might have the best or the strongest correlation with your target variable. All right. Let's not forget that in this our brief uh, project, our target variable here is the, okay, we've not been told yet. Okay, let's just proceed. So feature engineering, do we need to modify the data into different data types? Of course, machine learning model expects numerical data, or even to extract some parts of the data. So we have something to do here. So we should remove the loan ID to avoid accidentally using it as a feature. All right, so we want to drop the ID. It's very simple. Drop. But first, we need to tell me what's coming. That would be our loan ID. Plus. Okay, that's very simple. Count and data types per column. It's very easy. There are many other ways. There are many ways to do this, but don't waste your time. Just write loans.info to give you what this is asking us to provide. The count and data types for each column. So we have the count here and data types, very easy. So fortunately for us, there are no missing data here. So we just have to check for some distributions and relationship. All right, so I found out, so while in my preparation, I found out a very, very good distribution syntax, and it's the pair plot. The pair plot is, you would see that it will give us a very understandable, what is it called, relationship. So let's do this argument and then so of course the view will be the loan status, because that's what we are trying to determine. All right, so here to get show this. So let's see. So loans. Welcome, Rita. Okay. I would have loved to. The color is still okay. So let me see if I can enlarge it. State this to it. So if we look very closely, you would see that all right, relationship between applicant income and applicant income. So we have, of course, it will give us normal distributions. Looking at the relationship between applicant income and co-applicant income, realize that for those who have a loan status, of course, it's yes, is almost the same. So this will give us a very good idea on on the relationship between the columns, that we can be able to understand their relationship. Another way of checking that too is using our heat map to check the correlation between variables. But let's annotate it. It's true. Happy? Yeah. Then we get to the show. So look at this is almost the same thing here. The relationship between which is very strongly correlated. Loan amount and applicant income. That means that the loan that you will be given will be is strongly dependent on your income. These are insights that we can get from this data. All right. And also, the loan status is heavily dependent on your credit history. Okay. So we see strong positive correlation. All right. So sometimes you might want to check the frequency of your target variable, especially in this case where we are having a yes, a positive or a negative as per the loan status. So if you see 0 indicating for no loan status or negative loan status, and 1 representing yes. From here we see so loan approval status. I mean not loan, the loan approval status. If it's a yes or a no. All right. So from this our confusion matrix, if your credit history is satisfying, then you so the yes approval for your loan status is heavily dependent on your credit history. We are seeing a very strong correlation here. So let's check our loan status. Let's check the column and see the percentage or distribution of both yes and no approvals. We can use value count. But when we are using value count, if we want percentage, we always set an argument which is normalized. We set it to true. This is when we want it to be in percentage form. So let's call this. No, it's not fine. Oh, I'm not sorting this. Loans are not loan. All right, so 70% yes approval and 30% no approval. All right. We can also check for something. We can also check for what's it called? We can also check for the frequency of the loan status for each of the categories that we've had here. All right, you know, in our data set, we have let's go back to it. We have males, we have females, we have married, we have unmarried, we have those who have one dependent, two dependent, we have graduates, we have non-graduates, we have employed, we have not employed. So we want to check the relationship of if or each of these columns, each of the categories in each of these columns, the loan approval status. So a very beautiful way to do this. We could have done it written a line of code for each, but I think a for loop would be better. So let's say for every column, yeah, for every column in the loan column for the category, because we don't want to, because we also have numerical variables there, so we don't want to confuse. So we would define that the columns that we need are those where the type is equal to objects, yeah. Yeah, object. So let's not always forget this. I remember when I was still learning, I always forget this column. This column can mean a lot. I don't know. Are we following? Please, I need feedback. Can only see Victor. Okay, Bright just joined. Precious, good evening. All right, okay. So I'll go ahead. I know, yes, it's very simple for some of us, but it's the simple things that matter, the basics. You know, having a very good understanding of why, because I know that we have the advantage to ourselves, advantage of some of these AI agents like the chat GPT, all right, that can even help you to write code. But if you don't understand the why, you will just copy code from this and you will not be able to get your result, because you alone can be able to understand your data set, what you want to achieve more than an agent, right? And if you don't understand some of these syntaxes and their functions, when to use what and why, you just copy codes from ChatGPT. And I'm saying this because of the capstone project that you'll be giving. Yes, I said we're supposed to be giving towards this week, but then um, there has been some lag, and we're very sorry about that. So before Monday, Tuesday, we should be given to, sorry, before the end of next week, right? Because according to our calendar, the custom project is supposed to be given officially on the 13th, all right, but which is the last breakout session. But before then, to be given to for vetting. First giving back to. All right, so back to our projects. So let's continue. So for every column in the columns, for every column in the dataset loan, where the data type is equal to objects, what do we want to do? We want to do a count plot, as frequency. So a count plot plus our argument data. What else is in this? Yeah, your S column. Yeah, the S column. S column. Because your Y column automatically the loan status. So let's just use the all right. Then we so we've created a for loop. So if you're going to run this, you will discover that we're going to have many plots. So instead of writing different codes here for different what's it called? Different columns. So maybe writing X is equal to age, you write another. So what I was saying was, if we didn't use this for loop, we would have been doing something like this. X is equal to age, and you continue. X is equal to marital status, X is equal to, well, using this for loop will just help us. Okay, this is supposed to, it's not calling what? It's wrong. Okay. Oh, they don't use parentheses. Oh my god. Yeah, this is supposed to be not supposed to be because I'm so yeah. Okay, so this is for, so we have a higher percentage of loan a positive approval for loan for males than for female. We also have, so those who are married have tendency had more approval. Those who had zero dependents, of course, had more approval. Those who are graduates had more approvals. Those who are not self-employed had more approvals for loan. Makes sense. Those who are living in semi-urban areas had more approval for loan. So we see that this is giving us more and more better insights into our data set. This is now all of this you can do more, all right. Well, for the sake of our workbook, we'll just stick to templates here. All right. So the next thing to do is our modeling. So I'll just do things very simple here. Or should I ask a question? The first thing to do, of course, is to define your X and Y variable. In this case, our X is equal to loan. So let's use our loan amount for the course of this class. Let's just use our loan amount first. If you check, it's a float. Yeah, and then for our Y, of course, Y is always the target value. Loan. This is more like a guide, so you will ask to split. Remember, our X could have been any the columns that we want, but for the sake of our workbook, we're just following the template. We said we should create a first model using the loan amount. This is just to help you understand the basics of what you are doing. So, change to splits. So, how do we do this? X train, comma, X test. Then your Y train, then your Y is equal to train. I think we've imported the library for model selection. All right, train test, please. Thank you. We want to use 30%. Okay, first before we talk about, of course, we are doing this on X and Y. And I want to use 70% of our data to train and 30% of our data for the test. That's why we're using 0.3. But it's more like the norm. Test size to be. And then, of course, this is just the train. A random state set as 42. Then I need to check 5. So circle this function. All right, so let's preview the training set. How do we preview the training set? Since we are not using more than one column, just using a column for our X and a column for our Y. So let's check the training set. Print X train. Let's say the first 10. First 10 is not too much. Let's say the first 6. Sorry. Six. X and Y, right? So you can use forward slash, not forward. Yeah. Okay. What else? Okay. Same thing to first. Okay. See if it impacts. Actually, okay, so first scattered. Okay, so look at what we have. This is strange. Okay, let me just change because this is our C class. Okay. All right, so we just previewed our training sets. So let's what's it called now? Instantiate the model, the classification model. So I just need a response. Why is it a classification model? Anybody? I think I said that earlier when we started.
Because we are dealing with a case of yes or no scenario.
Exactly. It's a yes or no. A yes or no. Because at the beginning of the, or if you check the target variable, you see that it's either an approval for 1 and no approval for 0. So it's more like a binary classification. I think I said that here. Predict the binary outcome. If we were predicting a loan amount, it would have been a regression model, right? So what should we use? Let's use CLF, especially that's the norm. Instantiating, is we import, so let's confirm if we imported. Okay, yes, we did. Logistic. These are those basics, all right? To the right. All right. Okay. I've learned to always use this. Okay, so let's fit it. Because since we've instantiated, we just use CLF. The reason why you're instantiating is so that you will not be calling the, what's it called? The model every time. Sometimes you see you just use linear as if it's a linear regression, the regression model, or sometimes log reg. Sometimes I can use log reg here, or whatever it is I choose. So I just choose to use CLF. So I'm fitting the train data into this model so that you can what's it called? Train the model. The model can learn. Of course, after that, then predict. No. Right, that's the norm. Right, bread is equal to CLF. Predict X Also, in this case, our test data. That is one to test, and it's 30% of our data. 70% of our data was used to train, and 30% of data is test. Now let's check the model's first five predictions. This is actually just to help you understand the basics of. So, I want to predict the model's first five predictions. So, of course, our model is Y. First five will be this. First five. Huh? Okay. Oops. So, yes. Because if you check this, you see that the loan status. Let me see if we can see more. Yeah. Of our okay. Here we have a node here. All right. So look at the predictions that we made for the first five predictions, if you like. Now, after creating your model, there's need to check for the accuracy. You guys should have known this by now. And there are different metrics that are used to check accuracy. So accuracy, the basic of accuracy is to check the percentage and the fraction of the current predictions over the total number of observations. For your confusion matrix, we have four parameters. We have the TP, TN, FP, FN. You must have learned this in associated data science. I think one of the last three courses. I think it's hypothesis testing. So, true positive, correctly predicted as positive. True negative is when you make a correct prediction that this will be negative. Now, a false positive is when you predicted something as positive, whereas it was actually negative. And false negative is when you predicted something as negative, whereas it was actually positive. This is almost like a type 1, type 2 error kind of stuff, where you failed to reject the null hypothesis, whereas it was false. And a kind of error where you rejected the null hypothesis, whereas it was true. It's almost the same thing here. So if the actual is negative and you predicted negative, you have a true. If the actual negative and you predicted positive, you have a false positive. If it was positive and you predicted it to be positive, you have a. So if it was positive and you predicted it to be positive, you have a true positive. If it was positive and you predicted it to be negative, you have a false negative. So in precision, right? In confusion matrix, that calculate the precision is the number of total positives over the number of total positives and false positives. True positive rather than false positives. All right, so let's check accuracy here from what we just learned. We can use a simple way. We can use score first. And the courses on the test data. You're trying to check the accuracy of the test data. Test and one test. Right. Let's check. Since we have 70% accuracy. Now let's check our confusion matrix. Let's call it what to confusion. I think we call yeah. Now So of course we are checking the test data and what was predicted to be able to. Yeah, this is it. And then we need to display. So let's just call it display. Go to position and matrix display. This is supposed to be caps. Yeah, thank you. All right. This. And the confusion is equal to the conf as a variable. The display labels. So check it out. Remember, rejected is 0, approved is 1. All right. So let's see if we can run this. Of course, display. Let's not close this. Sorry. And of course, PLC that show. No. Let's put it in units. Let's put it. I think it's supposed to be starting. I think so. Yeah, yeah. Okay. This is our true label. These are predicted label. I think this column is for TN, TP, TN, FP, FN. Comparing it to this. This is not actually a good metric. So it means that when you have something like this, it just tell you that there might need to be some future engineering. The loan amount is not sufficient enough to make a very good prediction. So that's why we're now having these templates for us to be able to engineer some of the features. Just a very simple way. All right. So what we are going to do is we are going to use all of the columns, just as you know how. So loans go to pd.getDummies. Where for loans, let's say we are defining. Let's just use loan done. Let's preview our data frame. So it means that we need to carry other columns along. Right. Other categorical columns along. Drop. Okay, not yet. Yeah. So look at our categorical columns. Categorized for male and female, for married, for dependent, for education status, employment status, property area. All right, look at them here. All right. So we split into features and target, just like we did before. We are doing again. Changeable changer. All right, so X and Y again. Now, this time around, we are not just using one column as we did initially, where we use only the loan amount. So I think we're going to drop loan status column because we don't need it. Any questions so far, please? Before I proceed. Any question? What's our Y is equal to don't forget that this square brackets is always because if you just take one and make it one, it just gives you list not to take from. That's why we are using it. Well, any question, please? So somebody, I can't hear you. Yes? Somebody was speaking.
Okay, can you hear me?
Yes, I can hear you now.
Okay. During the exploratory data analysis, in some cases, you see them checking for data leakage and class imbalance. Is it a standard practice, or we can just assume the data doesn't have those defects and then we'll move on? Or is it must we have to check for those two factors?
That is the leakages and what?
Class imbalance.
Okay, leakages and class
imbalance.
Yeah, I think it's depending on the project. Most times when you're working on data lab, they kind of like try to see how they can just give you a very tailor-fitted data set. But sometimes you can have a data leakage, and data leakage is when the information from outside the training data, enters your model, and you now confuse, and sometimes you can also have a class imbalance. Say maybe, for example, maybe an oversampling and undersampling. It's just for you to look at the data set you are working with. If your data is not fitting well, or your matrix is not really giving you what you want, you might need to, especially for class imbalance where one class is dominating, and then to now ignore the minority classes, you can use a smooth in that case. Can import the smooth from the imbalance learning, where you actually more like resample. If you're having an oversampling and you want to increase the minority class, there's actually use smooth. If you are undersampling and you want to reduce the majority class, you use your what's it called again? Forgotten the model, random something, right? So sometimes you just have to check your data, or maybe if you're working with decision tree models, or in this case logistic regression, right? And maybe there are different class weights, imbalanced class weights. You can actually balance it using the argument class weight when you are trying to instantiate your model. That's at this point. Where is it? Yeah, at this point, you can use what we call the class weights. And set it to balance. Okay, so that's how to handle or you can maybe reduce the test size to 0.2. I don't know if I answered your question. I don't know if I answered your question.
Yeah, you've answered.
Okay.
Thank you.
So for the sake of others, sometimes for example, now if you are maybe creating a model and you want to predict if a customer, just like this loan status now, maybe you want to check if a customer will not talking about approval and rejection. Let's say, for example, you want to check if a customer will default on a loan, maybe he will not pay. All right, and there are some information that can only be captured in a data set after something has happened. So, for example, if somebody defaults on a loan, that's when you can now check the last payment date. Maybe the person was paying, and the person stopped. You can only get that information when the person has stopped. You cannot get the information before the person started paying. I don't know if you get. So, for example, I borrowed from OPay. I borrowed 50,000 naira. I'm supposed to pay an interest of 10,000, that's 60,000. And I started to pay 10, 20. If I stop at 20 and I refuse to pay for a long and exceeded the period, it is legit for me to have a data column that would tell me that, okay, yes, this data column is calculating or is giving us the last payment dates. If I had not started paying the loan, that information will not be available. So sometimes when you are making predictions, this kind of columns can cause problems, like this last payment date, because it's futuristic, right? And they can only exist after I've started to pay and stop. So it's actually making my model to learn the answer in a, like, it's cheating, because that's a data leakage. Data leakage happens when you have columns that have future information, like maybe, as I said, a payment history after an event, and also the data leakage can also occur when your target variable is appearing in amongst the features, hidden inside maybe another column or something. All right, or you're having a very, very high model performance. Of course, there are different ways to fix leakage. So it's either you drop those futuristic column, or you train, you test, you split your data before you start pre-processing. All right, that is before you start scaling. Yeah, like before you start scaling your data, your training data and your test data, you can actually train, test, and split them before you start scaling. Yeah, and we're talking about class imbalance. Say, maybe the count of a particular, let's say, for example, this loan status approve or non-approve. Maybe for approve, we're having like 95% in count, and then for the other rejected, we're having like 5%. You know, your model will always have tilt towards one side because it's not really balanced. Have to check that, right? Is I think I did that here, where we check the value counts of yes here. So you see, we're having 70-30. It's quite reasonable. If you're having something like 95.5 or 99.1, 98.2, I would say there's a class imbalance in that case, and maybe you might want to now increase the minority class in this case using smooth, yes, SNOT. So yeah, I'm very sorry, guys, but I have to go now because I have very low battery level. All right, so I guess we learned. I just want to quickly pass the information. So please, for those of us that have taken our certifications, I want you to help me do two things. The first thing I want you to help me do is share your journey, share your process on LinkedIn and Twitter, and tag AI Community Africa. You can tag your colleagues, you can tag any of the teaching assistants, right? So it's just to grow the community and put us out there. Share, don't be afraid. If you have been afraid of having an imposter syndrome, this is a good place to just blow your trumpet on LinkedIn and say, oh, look at the difficulties I had. Data camp bounced me back 2 times, this blah blah blah. I didn't understand this concept, but I attempted the certification exams and I passed flying colors. Look at the proof, look at my certification, look at my certificate. Just make the noise on LinkedIn, make the noise on Twitter, tagging AI Community Africa especially. And the second thing that I want us to do is, I don't know, I would still pass information on Discord. If you know you took the location, I would want you to provide your full name, all right, your full name, your email address, your data camp email address, and then your score, right? We need that information. The admins need, the AI community, we need that information, right? So we need that information so that we can be able to show proof to data camp that those who participated on the scholarship actually got certified and made good use of the scholarship. I'm sorry, did I? I'm not sure I pasted the attendance. I'm sorry. Sorry. So I'll just paste it now. So before we go off or after going off, you can just immediately fill it up. Oh God, everybody has been crying attendance. I'm sorry. I'm sorry. I'm sorry. I'm sorry. So, Bright, can you see the attendance link? You have been crying for it. Elizabeth, Bola, I'm sorry, I'm just seeing this message now. Sorry, I was sharing my screen, so I was sharing a different window, so I couldn't get to see. Messi, you can fill in the attendance if you haven't. Please help me reach out to Elizabeth or anybody that can reach out to her with this link, please. I think she has gotten off and she requested for the attendance link. Alpha, Victor, all right. So we'd call it an evening. Yeah, I know many of us have started the data science track, so we are there already. That's what we are treating or trying to understand properly, supervised learning. All right, so See you next week. Next week is actually going to be the last breakout session before we continue next year. See you. Get warmed up for your capstone projects. Make noise on your LinkedIn, make noise on your Twitter about your certifications. And then we need your information, your name, your data account mail, and your score. Thank you very much. Have a good night rest. So more information will be discussed, or any other thing will be discussed on the Discord channel. I have to go. Thank you. Yeah, let me clap for myself too. Good night. Oh, Mr. Osman, do you have any other information to pass to them? Probably you can. I'm leaving already. My 50% is very low. The tragic
No,
tragedy
no,
of
I think you already said everything.
hospital.
So
All right.
we meet next week, everyone. And next week is going to be our final breakout session. Please, if you've completed your certification, remember to post it on your socials. Remember to tag AI Saturday Lagos. Remember to tag AI Community Africa. Remember to tag Data Camp, because this scholarship is made possible by AI Community Africa from Data Camp Donate. Remember to tag them so that we'll be able to like renew it, and other people can also like enjoy the scholarship. And for everyone, we are actually not like going to like, you can take the data scientist track and the certification at your own pace. If you are not able to complete it this year, you can apply for the scholarship again next year. And if you get it, you'll be able to like continue with the data scientist track then. So you can take your time. But the capstone project is going to be assigned next week, which will be our last breakout session. Be sure to complete the capstone project so that you are going to get certificate of completion from AI Community Africa. So yeah, so I think that's it. And if you not complete your certification, please complete it, because that's one of the criteria to get certificate of completion from AI Community Africa. You must complete at least one track and you must get at least one certification. Please, let's do that. Complete the capstone project, and then you can continue the data scientist track at your own pace. Apply again for the next batch of scholarship to continue at your own pace. Yeah. So we see you. We see next week. Thank you, everyone. Thanks for coming.